The small hardwood floors in indoor stadia. Basketball courts have come a long way since the late 1800s, while the rules and exact line layout have evolved over time. The basic basketball court layout remained the same in 2001 as it was in the 1940s. The first basketball court was limited to the size of the college gym in which it played. In 1891, physical education teacher James Naismith invented the game at Springfield College in Massachusetts. Naismith used pitch baskets for the hoops. Naismith listed no specific size for a basketball court in his original 13 rules. Instead, players adapt their game according to the gym. YMCA gyms across the USA host many of the earliest basketball games. The governing organizations for basketball measure the distance of the free throw line from the front plane of the backboard. The NBA, the NCAA, and the National Federation of State High School Associations dictate that the free throw line is 15 feet horizontally from the plane of the front of the backboard. The free throw line on international courts is 50.09 feet from the backboard. The edge of the hoop is 6 inches from the plane of the face of the backboard. The ring has an interior diameter of 18 inches. This places the front edge of the hoop about 2 feet from the backboard. The free throw line is about 13 feet horizontally from the front edge of the hoop. International hoops must be a minimum of 450 mm and a maximum of 459 mm, which is between 17.72 and 18 inches. The free throw line is approximately 13 feet horizontally from the face of the backboard, and 16 feet 5 inches measures point to point through the air. Court for NBA games in the US are 19.4 feet long and 15 feet wide. College courts, men's and women, are the same size as NBA courts. High school courts are a little shorter at 84 feet long, but the same width, 50 feet. Courts governed by the International Basketball Federation or FIBA. For international competitions are close to NBA size, but they are measured in millimeters. Courts for international games are 32,000 mm long by 19,000 mm wide, which is 91.8 feet by 49.21 feet. Playground basketball courts are typically created at the same specifications of other courts, with the free throw line being set 15 feet from the backboard. However, there is no regulations for playground courts, so the dimensions could be different from those used in high school, college, or professional games.
Next, we will present about the surface area and the volume of the basketball, which is sphere. The diameter of the basketball is 24 cm. Use pi equal to 22/7. To find the surface area, we can use the formula pi diameter squared. The calculation is 22/7 multiplied to 24 squared. So, the answer is 1810.2857 cm squared. To find the volume, we can use the formula 4/3 pi radius QB. The radius of the basketball is 12 cm. So, the calculation will be 4/3 multiplied 22/7 multiplied 12 QB. The answer is 7,241.1429 cm QB. Next question, based on the picture, find the area of the basketball court. We will use the formula area of rectangle, which is width multiplied to length. The calculation is 28 meter multiplied to 15 meter, and the answer is 420 meters squared. To find the area of the center circle, use the formula 1/4 pi diameter squared. The calculation will be 1/4 multiplied 22/7 multiplied 3.6 squared, and the answer is 10.1788 meters squared. Next, based on the picture, find the angle of elevation from the player to the basketball hoop. First step, we will draw the triangle. To find the opposite side of this triangle, we need to subtract the head of basketball hoop and the head of the player. So, the opposite side will be 122.8 cm. To find the angle of elevation, we can use the formula tan theta equal to opposite over adjacent. To find the angle, the calculation will be inverse tan multiplied to 122 over 257.2. So the answer is 15.034 degree.
Dice are small, throwable objects with marked sides that can rest in multiple positions. They are used for generating random values, commonly as part of tabletop games, including dice games, board games, role-playing games, and games of chance. A traditional die is a cube with each of its 6 faces marked with a different number of dots, picks, from 1 to 6. When thrown or rolled, the die comes to rest, showing a random integer from 1 to 6 on its upper surface, with each value being equally likely. Dice may also have polyhedral or irregular shapes, may have face marked with a numerous or symbols instead of picks, and may have their numbers carved out from the material of the dice instead of marked on it. Lot dice are designed to favor some result over others for cheating or entertainment. Dice and Geoporanas are the oldest gaming implements known to man. Sophocles reported that dice were invented by the legendary Greek mathematicians during the siege of Troy, whereas Herodotus maintained that they were invented by the Lydians in the days of King Atticus. Both inventions have been discredited by numerous archaeological finds demonstrating that dice were used in many earlier societies. The precursors of dice were magical devices that primitive people used for the casting of lots to divine the future. The probable immediate forerunners of dice were knucklebones, as well the ankle bones of sheep, buffalo, or other animals. Sometimes with markings on the foreface, such objects are still used in some parts of the world. So, how to use the dice? Dice are thrown onto a surface either from the hand or from a container designed for this. The face of the die that is uppermost when it comes to rest provides the value of the throw. The result of a die roll is determined by the way it is thrown according to the laws of classical mechanics. A die roll is made random by uncertainty in minor factors such as tiny movement in the thrower's hand. They are thus accrued from a hardware random number generator. One typical contemporary dice game is craps, where 2 dice are thrown simultaneously and wagers are made on the total value of the 2 dice. Dice are frequently used to introduce randomness into board games, where they are often used to decide the distance through which a piece will move along the board.
This cube dice has 12 sides of the same length, 6 surface and 21 circle surface. Formula for volume of cube dice is length multiplied by width multiplied by height, or we just use length cubic because cube has sides of equal length. Example, what is the volume of cube dice whose at length 6 cm? Volume equals to length cubic equals to 6 cubic, and the answer is 260 cm cubic. Cube dice has 6 equal surfaces. Formula for surface area of cube dice: total of surface multiply surface area of a shape. So, formula for surface area of cube is 6 multiplied by a square. Example question: the length of the side of the dice is 6 cm. Find the total surface area of the number cube dice. Surface area equals to 6 multiplied by a square. A square equals to 6 multiplied by 6. The answer is 39 cm square. So, the answer for surface area of cube dice is 6 multiplied by 36 cm square. So the answer is 260 centimeters square. We also can find the length of diagonal in a cube dice. It is because cube dice has a 90 degrees angle. To find the length of the longest diagonal of the cube dice, we use the Pythagoras theorem. So the question is, the length of the side of the dice is 6 cm. Calculate the length of the longest diagonal of the cube dice. We use the Pythagoras theorem. C square equals to A square plus B square. C square equals to 6 square plus 6 square equals to 72. To get a C, we have to square root 72, and the answer of the longest diagonal in cube dice is 6/2 or 8.4853. One dice has a 21 circle surface, so formula for a circle area is A equals to pi r square. If given the diameter of the circle in a cube dice is 1.6 cm, find the sum of area for 21 circle surface that have in a cube dice. Use pi 22/7. A equals to pi r square. To get the value of r is diameter divided by 2. 1.6 divided by 2 equals to 0.8 cm. Area for one circle is 22/7 multiplied by 0.8 square. The answer is 2.0114. The sum of area for 21 circle surface that have in a cube dice is 21 multiplied by 2.0114, and the answer is 42.2394 centimeters square. In conclusion, MAT123 has demonstrated numerous applications to daily life. The course is designed to expand into a variety of areas which students in engineering, mathematical or arts may find more applicable. This subject has also existed many practice in the construction of something based on the concept of geometry.
Such as every object exists with their own shape. As you have seen, there are many unique buildings that have been built in this work by knowledgeable people who study geometry. Other than that, starting from the history and background of geometry, I recognize the connection between mathematics and world history. In addition, the science of geometry also have a major impact on evolutionary change in the world.
Furthermore, studying geometry provides the student with many foundational skills and helps them to build their logical thinking skills, deductive reasoning, analytical reasoning, and problem-solving skills, thus contributing to their holistic development. Also, it finds huge application in the real world as it helps us in deciding which material to use, which design to make, and even plays a vital role in the construction process itself.
Last but not least, this assignment has improved our skills in the subject of geometry to a higher level. In both cases, we can understand how geometry is applied to them by using some formulas that we usually use to solve geometry questions. As a student studying this subject, this project is very useful because it increases the amount of experience in the subject. In learning geometry, not as a subject, but as something useful for their lives. Geometry is a very important asset. Without it, work cannot develop as it is.